For my lab, I was assigned bivalve mollusks. Here's a picture of one of the largest bivalve mollusk fossils ever found. It's in the Copenhagen Zoological Museum, and it's huge. It's about the size of a person. They are the phylum Mollusca and the class Bivalvia. It's pretty easy to remember bivalve mollusks. Origins. So they evolved more than 500 million years ago during the Cambrian explosion. Their outer shell really helped to preserve them in the fossil record. And their appearance, at least outwardly, has remained remarkably unchanged during all of this time. If you were to see a bivalve 200 million years ago, it would look very similar to a bivalve today. And they're still alive today. Clams, oysters, mussels, and scallops are all examples of living bivalve mollusks, and there are more than 15,000 species still alive today. They're found pretty much all over, both freshwater and saltwater, shallow, deep water, and they live in a variety of places: vegetation, mud, buried underneath mud or sand, or they dig themselves into rocks. So you can find them open ocean, shoreline, estuaries, um, rivers, lakes, just pretty much everywhere. And they're pretty easily recognizable. Um, they're a soft-bodied organism covered in a shell that opens on a hinge, kind of like a book. The colors vary greatly, but that basic shell structure remains. Um, they're very similar in appearance to brachiopods, but the biggest difference is the symmetry. Um, Bivalves are symmetrical along their hinge, so they open like a book, and that's where the symmetry is, right at where the spine of the book would be. Whereas brachiopods are symmetrical just down the middle, so you'd have to like saw them in half. And they don't have a head; they only have a foot, which is pretty interesting.